If the branch of the military changed the height requirements so that all women are eligible, except the shortest 1% and the tallest 2%. The question is, what would our height restrictions or height requirements be? All right, let's start by drawing our normal distribution. And let's sort of wrap our minds around what this question is asking us. And here's our mean, of course the mean, which is our, let's fix that. I was doing an X bar. This is a population, so our mean is mu, which is 63.8%, inches. We're looking at the left tail, so the sort of 1% here. This is, I'm going to say that we have this sort of tail here, and we want this tail right here to be 1% or 0.01. And then we have another tail here. These are not to scale, but we want to say we have another tail here. And we want this tail to be 0.02, and that's the area under the curve. So what we're looking for is we have this is the area or heights along here that are acceptable. And so we want to find the z-score such that the area to the left of the z-score is 1%, and the z-score here such that the area to the right is 0.02%. So we're looking for two z-scores. We'll call this z left, and this is our z to the right. And once we find these z-scores, we will be able to find the corresponding heights of these z-scores, because we're going to use the formula such that the z-score is equal to the height, that's what we're looking for. We'll have the z-score minus the mean, and we know that, 63.8, divided by the standard deviation. And of course, we know our standard deviation is, let me write this down here, our standard deviation is 2.4. Okay, so we're going to have to go back to our tables to go find what the, to find these z-scores. We want to find the z-score, so we're going to go to our table and find an area to the left of 0.01 using our table. So let's do that. So when we look at our table, this part of the table, this here, these are our p-values, or area under the curve, and this column gives us our z-values, and these are also z-values here. So this is a z-score of -3.4 here, where we have a p-value of 0.003. This is a z-value of -3.41, where we have a p-value of 0.0003. And we're looking for 1%, which is 0.01. 0.01 starts, let's see, looks like we get to 0.01 right here. We have a 0.01, and there's a little bit more, 0.07. So this is a 1.07%. And the p-value, so let's circle that. Let's put a circle, because this is going to be this looks like the closest to a 1%. And so for this value, we have, this is a 1.07%, very close to what we're looking for. And the z-score for this, we can see, is -2.3. So we'll start with the -2.3, and then there's a tailing value. So -2.30, and there's no values after that, so it's a -2.30. So there's our left-hand z-score. So our z-score for 1% is negative 2.3. So let's take a look at this equation here. And what we want to do is we want to find the x value that corresponds to this z-score. I probably should have written it down here, our low z-score of negative 2.3. What's the x value? And so we know what our z-score is. We know the standard deviation. Oh, excuse me, that down here. And we know our mean. We need to find x. So let's do that. Let's solve for x. All right, and let's do that on the next page. Stop. Let's do a solve for x with that equation. Given the formula that our z-score is x minus our mean divided by our standard deviation, what we want to do here is we want to solve for x. So I'm going to multiply both sides by the standard deviation. I have z times the standard deviation is equal to our height, x, minus the mean height. Remember, we're solving for x. So I'm going to add the mean height to both sides. And I have z times the standard deviation plus the mean height gives us our actual height for that z-score. And what I'm going to do is I'm going to use symmetry and move the x to the other side. We're solving for x, so x is equal to our z-score that we found times the mean plus the standard deviation. So let's solve for our x to the left, and our z-score was a negative 2.3. And this is multiplied by our standard deviation, which is 2.4. And we add to this our mean height, which is 63.8. So let's get a calculator and find out our left-hand x value, which is our left-hand height, minimum height. And what we get here is a height of 58.28 inches. That's our left-hand height. So our left-hand height is 58.28 inches. And now what we want to do is we want to find our right-hand height. We'll put an X. This is our right-hand height, our left-hand height. So to do that, we're going to do the same thing. We're going to go back and we're going to take our, look for a p-value of 0.02, 2% to the right. So now we have to look at our right-hand table. So here we have our positive z-score table. And the positive z-score table is going to give us the area to the left of our positive z-score. Well, what we're looking at here is we want this area to the right to be 2%, which is 0.02 to the right. Well, since the positive z-score table is giving us this area, then we're going to want to look for an area to the left of 1 minus 2%, minus 0.02, which if you take 1 and subtract 0.02, you should get a 0.98. I'm writing very small. It's a little challenging. Okay, 0.98. So we want to look for a value of 0.98 for our positive z-scores. And we're going to find that in here, in the body of it, of the table. And if we look at all the way over to the right, the furthest we get is 0.9177, which is 91.77%. We want 98%. So I need to keep looking down. So let me go get the other half of that table. So here's the other half of the table. I couldn't quite fit the entire table on one page. So I have the top that we looked at. Now here's the bottom of the table. And I'm still looking through, looking for a 0.98. Let's see if we can find that. We've got it 0.99. Let's walk back. There we go, 0.9871. There was still 0.98. And we've got 0.98 here. We want to get as close to 0.98 as possible. 0.9821, that brings us up to here. Here we've got, oh, here we go. 0.9803. That looks like the closest we're going to get. Let me put a circle around that. A 0.9803. That is 98.03%. Very close. And so the z-score for that, we can see, is 0.2. And then we come up here and it's 0.6. So the z-score for this is, 2.06. 2.06. So that's our right-hand z-score, 2.06. So our right-hand z-score is 2.06. And what we want to do is use that right-hand z-score to find the right-hand height. Okay, so the z-score we found for our right-hand height, we're going to put that one in to find the right-hand height. So the z-score we found was a 2.06, and we multiply that by the standard deviation of 2.4, and we add to that the mean of 63.8. And let's get our calculator out and calculate this answer to this. And we get a 68.744, but we'll say 4 inches. So these are both inches. So our heights for this new requirement height for the military would be anyone between 58.28 inches and 68.74 inches. And to meet the requirement for my math lab, we would have one significant digit to the right of the decimal point. So our left-hand height would be 58.2, and our right-hand height would be 68.7. And of course, if you were rounding it, this would really be a 0.3, but then my math lab wants you to truncate off. And so there's our low height and our high height.